Hi all, this is my video number 26, number 26, and as promised in the last video that I will give example on how to convert the initial value problem into the Volterra integral equation. Yeah. So this is quite, I think, rather short video because I only have two example, not that long. So let's begin those things. So this example form an integral equation. For the initial value problem, we have the 2y dx squared minus 5 dy dx plus 6y equal to 0, with the initial condition that y not equal to 0 and y prime not equal to 0. Minus 1, sorry. 1 y prime not equal to minus 1. Okay, so the solution is just look at this step that I have explained quite long approach or method that I explained in the last video. So first thing, we let the 2y dx squared, the highest order of the differential equation, we let this equal to function g, right? And g is unknown, and then we integrate. So let's call this equation number 1. Okay, so then we integrate 1 from 0 to x, from 0 to x, because our initial condition here is x equal to 0 to some x. So x from 0 to x with respect to x. Okay, so that give us, we integrate this. So integrate from 0 to x d2y dx squared dx, that equal to, we integrate from 0 to x gx dx. Integrate d to y, that give you y prime. Then we evaluate from 0 to x. So that give you dy dx minus y prime 0, that equal to integrate 0 to x gx dx. Okay, and we can use the first initial condition given in the question here, which is minus 1. So therefore we can write this as a dy dx equal to integrate 0 to x gx dx, and we bring it to the right side. We have minus, so this is plus, you got minus 1. Okay, and then we change x and y. So let's call this equation number 2. Let's call this equation number 2. Then we change this into x and y, then rewrite 2. So we have dy dx, this is equal to integrate 0 to x gt dt minus 1. Okay, let's call this equation number 3. And then we integrate again 3. Integrate this again from 0 to x with respect to x. Now integrate 3 from 0 to x dx. That will give us so integrate this, we have y from 0 to x. So that give you yx minus y0. Okay, then integrate this twice. We already got once, and then we integrate those. We got a to x gx squared dx squared minus, integrate that one, we have integrate a to x, oh sorry, this is 0 to x, 0 to x dx. Alright, and for this part here, we use the relation. Yeah, we use then using the relation, integrate a to x yt dt to n, as we have integrate a to x x minus t n minus 1 over n minus 1 factorial yt dt. Okay, that one you can evaluate that one. Okay, this one we can use this relationship, and then y naught from the given initial condition. Then from there we obtain, so therefore we have y, yeah, that equation here. Just bring it to the right hand side others, then use that relation using this initial condition. Then we have y, or you want to write yx. This is equal to integrate from 0 to x minus t gt dt minus x. Yeah, because y naught is 0 from the initial condition. Okay, so we have this. Let's call this equation number 4. This is, we have x. Yeah, let's call this equation number 4. Alright, and then we can write this, change x and t. We also have y equal to 0 to x, so we have x minus t gt dt minus x. Well, I think this is just the same thing. This should be gx here, yt x. Okay, so that should be gt dt minus x. So this is equation number 5. And then we substitute this dy dx. Where is dy dx here? 1. Okay, and then dy dx, which is 3, and y 5. So 1, 3, and 5 into the given equation here. Yeah, into the given equation. So what we have, so let me write those things. We substitute 1, 3, and 5 into the given differential equation, or I would say differential equation. So what we have, that will give us, we have d2y dx squared, which is gx, okay, and then minus 5 dy dx. Our dy dx is given as, we obtain as 0 to x gt dt minus 1, okay, and plus 6y. So plus 6, our y is given, we obtain as 0 to x minus t gt running out of space, dt minus x, alright, that's equal to 0. Okay, then simplify those, alright, that gives us, we have gx, right, in term as a standard Volterra integral equation. We have unknown on the left hand side, and the rest we put it on the right hand side. So we have here gx is equal to, we have fx, which is from here you got minus 6x, you bring it to the right, so we have 6x, alright, and then we have here plus 5, you bring it to the right, so we got minus 5, and a plus, and so we have integrate 0 to x, so we have here minus 5g, you make to the right side, so we have plus 5, here you got x minus, so put it together, so we have 5 minus 6t 6x plus 6t gt dt. Okay, so from here we recount that this is our fx, which is known, should be, alright, and this is our kernel kxt. So what we have done is that the initial value problem, this initial value problem, we reduce into the form of like ux is equal to fx plus integrate 0 to x k xt ut dt, which is the limit of integration is 0 to x, which is the Volterra integral equation of the second kind. Volterra integral equation of the second kind. Okay, so in general it's not that difficult as compared to, if you compare to the my previous video, it look like quite tedious because that's involved in general terms dn y dx n, but when we apply to the, for example, second order differential equation or third order differential equation, and what else if just a first order differential equation, so the process is quite simple. So let me give you another example here. Example number 2. So let's say we have the differential equation d2y dx squared plus x dy dx plus y that equal to 0, with the initial condition y0 equal to 1 and y prime 0 equal to 0. Alright, so first is that we let the highest order d2y dx squared, so let solution, let d2y dx squared equal to gx. We put this as equation number 1. Then we integrate 1 from 0 to x. 0 to x. Integrate 1 from 0 to x. With respect to x that we obtain, we have dy dx. Yeah, evaluate at x, and then minus we evaluate at 0, so we have y prime 0. And the right hand side that give us integrate a to x, 0 to x, g x dx. Okay, and then we apply the given initial condition that give us dy dx is equal to, that one is 0, so what left we have 0 to x gx dx, and then we change the variable x into t in the integral, or I can write this as a dy dt, dy dx. This is equal to integrate 0 to x gt dt. Okay, so let's call this equation number 2, this equation number 3. Then we integrate 2 from 0 to x dx. So what we have is that our 2 is this one. We integrate those, so we got y x minus y no. Alright, so this give you yx. Oh, what happened to my pen? Just jump everywhere. Okay, so yx plus minus y naught. Okay, and this equal to integrate from 0 to x gx dx squared. Okay, and then that give this is the initial condition, which is 1, and bring it to the right side. So we have, this is yx is equal to 0 to x gx dx squared. This is 1, so we have plus 1. Alright, just a minute, my handphone running out of battery, need to charge this. Alright, so and then we can use the relationship that I given earlier for this, where we have where is it? We use the relationship integrate a to x y t dt n. This is equal to integrate a to x minus t n minus 1 over n minus 1 factorial yt dt. Yeah. So for this, we use that relationship, then we obtain that give us yx yx, this is equal to integrate from 0 to x, this will have x minus t gt dt plus 1. Now we have a, where is my paper? We have y double prime, we have y prime, and we have y. This is equation number 3, number 4, is it? Yeah, this is equation number 4. Alright, and we change x to t already. Okay, so we have those things. Now we substitute everything in those things. Substitute dy dx d2y dx squared dy dx. Yeah, we have d2y dx squared from our first step that we let d2y dx squared equal to gx. Okay, and then we find dy dx. Okay, and then we find x. So which is those equation from where is my paper? So we have here 1, 3, and 4. Yeah, which is from 1, 3, and 4. Okay, we substitute this into the given differential equation. Yeah, substitute this into the given differential equation. So what we have, our differential equation is here. So d2, this one given here, d2y dx squared. So this is gx. So we have gx plus our x dy dx, x dy dx. Our dy dx is here, number 3, which is 0 to x gt dt. So we have x 0 to x gt dt, and then plus y. Our y is given in equation 4 here. We have integrate from 0 to x minus t gt dt plus 1. Alright, so all these things, this is a y, this is y prime. Alright, then equal to 0. I put it in bracket so that we are still we are not confusing, because this is for y, this is for y prime, this is for y, and this is for y double prime, d2y dx squared. Alright, and then we can rearrange this. Rearrange that give you gx is equal to, so you can write the function in front, that one. So you got minus 1. Alright, and then the rest you can bring it to the right side, that you have minus integrate 0 to x. So we have here we have 1x, here you have another 1x, so we have 2x. So we have 2x, and then minus t gt dt. And at once we reckon that this is our function, known function. This is our k xt. So then this is the, and then our integration is from 0 to x. So this is the Volterra integral equation of the second kind. Of course, here you can, this negative you can put it plus by changing the order of inside. You just multiply that inside. So therefore, this is the Volterra integral equation of the second kind. Alright, and I have one more example. So let's look at this another example here. Example number 3. So we have, let's say we have d 2y dx squared minus sine x dy dx plus exy equal to x with the initial condition y0 equal to 1 and y prime 0 equal to minus 1. Okay, so we follow the same step. First thing we let the highest order in this case is d2y dx squared. So we have d2y dx squared. We let this equal to gx. We take this as equation number 1. Differentiate that, integrate those things. So integrate 1 from 0 to x. From 0 to x 1 dx. That gives us, we have yx minus y prime 0, that equal to integrate from 0 to x gx dx. And then using the given initial condition, that we have yx is equal to integrate 0 to x gx dx. Our initial condition, this is minus 1, minus plus, then we bring it to the right side, this is minus 1. Okay, so and also we can write this. So let this equation number 2, then rewrite those. Rewrite 2. So we have yx, this is equal to 0 to x gt dt minus 1. That's called this equation number 3. Then we integrate 2, yeah. Then integrate from 0 to x 2 with respect to x. We have, so it's the step is similar for all these 3 examples. You just follow the step one by one. So we integrate this 2. This should be 1 y prime, yeah. This should be y prime. And this is y prime. Yeah, dy dx y prime. So we integrate this. So we have yx minus y0. On the right hand side, we integrate those. This is equal to 0 to x gx dx squared. Alright, then integrate this. We got from 0 to x, we got minus x. And then we use the given initial condition, which is 1. So what we have from the boundary condition, yeah, from the boundary condition, so we have yx is equal to, so we have this is 1, bring it to the right side, got plus 1. So we have basically 1 minus x. So 1 minus x plus integrate 0 to x gx dx squared. And then we use the relationship. This is equation number 4. Alright, equation number 4. Should I put 4 here? Yeah, 4. And then we use this relationship that I've given earlier. So what we have in this case is that this is equal to integrate 0 to x minus t gt dt. So those equation becomes, so we can write this as a yx 1 minus x plus integrate 0 to x minus t gt dt. Alright, this is our equation number 5. And then we substitute all those things 1, 3 and 5. 5 is that one. Okay, then substitute everything 1, 3 and 5 into the given differential equation, into the given differential equation. So what we have, we have d2y dx squared, this is gx minus sine x, minus sine x, and we have dy dx. Our dy dx is here. Alright, so you can write this is integrate from 0 to x gt dt dy dx minus 1, okay, plus we have exponent to the x, y. Our y is number 5, equation number 5 here. So we have those so equation number 5, this is 1 minus x plus integrate 0 to x minus t gt dt. Alright, then equal to x on the right hand side, equal to x. Then we simplify this. Simplify this will give you gx is equal to, so here we have gx on the left side, and the rest you bring it to the right side and we arrange in this form. Ux is equal to fx plus integrate from 0 from a to x, in general from a to x. Alright, k xt ut dt, because this is the Volterra integral equation of the second kind. So we arrange those in that form. So we obtain from there, this is just look at those things. So we have x, correct? So we have x, so we have x minus x, that one, minus sine x, and then minus e to the x, 1 minus x, right, plus integrate from 0 to x. We have sine x minus, here we have ex, x minus t, gt dy, gt dt. Alright, so this is our Volterra integral equation of the second kind. So this our fx here, so let me write it like that way. This is our fx, Alright, and this is our kernel KXT. Alright, so with those three examples, how do we convert from initial value problem into the Volterra integral equation of the second kind? There's three examples. If you notice the step, everything is just the same. You just follow the steps, so it's not that difficult. All right. So I stop here for this video. See you in the next video. Yeah. Bye bye.